In this installment, we are definitely going to plug this set in and turn it on. When I last left off, I had said I needed to do a little bit of homework. That's because this came from a combo set. There's a plug on this power supply that I don't have anything plugged into. That's where the radio goes. Now remember, there were notes in the service info about how to operate just the radio or just the TV if you didn't have both hooked up. And it said you need to short out 2 of these pins to operate the TV, and that restores the heater supply. That puzzled me because I knew from working on these before and looking at the schematic that the heater, some big heavy wires coming off the transformer, and it goes to 2 pins on the connector, the main power connector, which go to ground on the main chassis, and then the other 2 go to E and F, which has 2 heaters. So, with that being plugged in, all the tubes should light up, right? Well, no, because there's this one. Pin 4 of V305, pin 2 of V406. That goes up to the TV interconnect. So what are those? Well, V406 is a horizontal output tube. What this boils down to is when you're in radio mode, they kill power to the horizontal output tube, you get no high voltage, disables the TV. What doesn't make sense to me, though, is pin 4 of V305. V305 is the AGC tube. And yeah, pins 3 and 4 and a 6AU6 are the filament. Why would you care about killing the filament juice to the AGC tube and leave everything else lit up? And you might think, well, hey, maybe the radio uses the same IF tubes and you want to disable the AGC so you get maximum gain or something like that. No. The radio is 100% independent of the TV except for the power supply and the audio amp. But it doesn't use any of this stuff. I mean, theoretically, like for an FM radio, you could use this circuitry because FM radio lies between channels 6 and 7. But they don't. It's totally separate. What I was expecting to see is that it would kill the filament to V307, a picture tube. So we'll find out when we're running this, but it seems like when you have the radio on, they leave the picture tube filament running. Great for instant on if you want to flip back to watching the TV, I suppose, but not so great for the life of the picture tube. I've seen some sets go to the opposite extreme, like the early GEs, the 801, the 802, the big monstrous consoles. Those have a massive mode switch that kills the juice to all the TV tubes. Downside is that switch is a high failure rate because you're switching like 10 amps of filament current or something on that order. So I can get why they don't want to cut the juice to all the tubes. That may be a modification worth making. I talked to the owner about that. He's going to be operating a radio a lot. I think we should kill the juice to the TV tube filament. Anyways, all that matters right here, right now, is I got to short those out. What I'm still a little puzzled by, though, is this wires coming out the front. There's 4 wires. Whereas there should only be 2 because this output transformer, I do believe, is on that chassis, so you just got 2 wires going to the speaker. I think the other 2 might be for a pilot light on the cabinet. I got to trace that out, figure out what these wires are supposed to go to, and hook up the speaker. And it also occurs to me, I'm going to try powering this up first without that jumper in place, because that's cool if everything powers up without the horizontal output tube. I don't need high voltage just to see if this thing will turn on. Okay. I installed a proper 1/4 amp fuse underneath this set, although I don't put the jumper in, so the horizontal output tube is going to be disabled. And I did verify it disables the horizontal output tube and the AGC tube on this chassis, but it also disables the 6X5 on this chassis, so there's no B+. Kind of a weird arrangement, but that's what they do. Alright, so, well, I guess that's that. I clipped off the leads going to the 6.3 volt pilot light. That's what those 2 wires were for, and I cut off the wires going to the phonograph lead. So I think we're pretty safe in that regard. The set is turned off right now. I'm going to turn on on my PR57. Check the output level. Switch to current mode. And here we go. Cool. Current shot way up and dropped off. That's what it should do. We got some tube glowage. 6x5 is off. That's right. Fortunately, picture tube is lit up, but that's the way they designed it. Horizontal output tube is also off. And I think that's the AJC tube. And everything else seems to be lit up, so that is correct. Some of these tubes are a little bit askew. Sure everything's seated properly. Alright, cool. And the current is holding steady. Excellent. Audio output tube's also lit up. Do hear a little something out of the speaker. Alright, so now I'll put that jumper in. Here we go. Full power test. Should draw a bit more current now. Enough. I may have to go to the higher range. We'll see when the tubes warm up. Yep, 6x5 is lit now. As is horizontal output tube. Excellent. And screw that up. Yep, there goes the current. Sure sounds like we got a horizontal oscillator screaming. Looks like I'm on the 1.5 amp range on my current meter, and it's just at the edge of that, which seems about right. No idea how any of these controls are set. Okay, so that's volume. And we got static, that's cool. That is focus. One of these is brightness and one is contrast. Got nothing, however, move the ion trap magnet, so I'll loosen that guy up, move it around. Oh, that's not a good sign. Just moving that magnet. Here we go again with some alligator clips on the antenna leads, and I stuck on a channel knob so I can change the channels. I think that's 6. Sure sounds like the horizontal's running. Get a high voltage probe and check some stuff out. And we got some sound. Well, that's a good sound. Weak though. I mean, for push-pull 6K6 output tubes, and this is pretty strong. It's actually a broadcast station at the edge of TV channel 6 and FM radio 87.7 kind of coincides. This is actually a very strong audio carrier, so it should be blasting out of there, and we're barely getting it. And boy, that loud sound is really annoying. I can see some blue glowage inside the electron gun too. But that to me does not look like it's gassy. It looks to me like we might have some incorrect voltage somewhere. So that will definitely require some checking. Could just be that I want to play around with this a little bit. Maybe we just got a loose connection somewhere. Grab a high voltage probe too. Let's see what's really going on. Okay, high voltage is kaput. It's like 300 volts. Far short of the 8 or 9,000 it should be. So I'm gonna try tweaking that horizontal oscillator coil and the drive and see if I can get that any better. Okay, 3 things. 1, audio is much louder now. Not sure why exactly. Maybe one of the antenna leads wasn't clipped on that well. 2, the drive control was backed way out. I tightened it all the way down, which actually decreases the amount of grid drive to the horizontal output tube, and then backed it out like half a turn, which is what you typically would do. And finally, I adjusted that horizontal oscillator coil, and I think you can hear it's a lot quieter now. So it had been kind of like that, and I went down until it got quiet, and now I'm getting about 5,500 volts. So I think now, if I play around with the ion trap magnet, yes. Well, hey, ho, hee. Check out the focus, and hold, and horizontal hold. Oh, gotta tweak that back control a little bit more. Looks like my going over everything meticulously is paid off. Wow, this coil is way, this coil is way off. I can't think of this as a super coarse horizontal hold. Oh, I just went in so far. Oh, there we go. I'll have to play around with this a bit to get it right. Vertical's locking quite nicely. Horizontal is really close. Looks like we got about 3 or 4 images there. And now for a test with a strong signal source from an over-the-air converter box. And you know, I was talking about the sound not being so good. It just occurred to me, I replaced the mic caps in these audio IF cans. They got to be off. I'm sure with some tweaking it will be a lot better. Ooh, got a little bit of irking. I wonder where that came from. Anyways, so let's see with a strong signal source if we can get a better, well, get a picture and see if we can get some horizontal hold action. So I'm pretty sure it's 2, 3. That's sound. So this, the outer control here must be brightness. So this would be contrast. It's really doing a whole lot. It's weird because it seemed like I got more of an image when I was using a weak over-the-air signal than with a really strong direct signal. Now there is a slug in here, one for each channel. That's what this cutout here is for. It could be really far off, such that the visual carrier is not coming through. So I better see. Am I on channel 3 or 4 with this thing? I am on channel 4, that's what I thought, but it seemed to be getting a better picture on channel 3. Switching this to 3. Also, I didn't replace that. So there's the one electrolytic on the sound ratio detector. I haven't replaced that yet. But it could very well be as simple as a weak tube, like the video output tube. Considering all the other issues this set has, I mean, I have no reason to assume that the tubes were tested properly. I'm just a little perplexed why I seem to get almost a stable image with a weak signal, and then with a strong signal I got like nothing. Just for the heck of it, before I test the tubes, I noticed that there were two 6SN7s in this set. One horizontal oscillator, one vertical oscillator. So I swapped the tubes. Now no high voltage, the horizontal oscillator isn't running. So I'm really thinking now we've got some flaky tubes in this set. So I'm going to go through and check them all. No point in wasting time. Anyway, I have a whole bunch of TV tubes to test. It's hard to beat a cardmatic. For those of you not familiar with a cardmatic, it is a tube tester that, pardon me while I plug it in, that uses punched cards rather than a bunch of knobs to set the various parameters. So, let us find the 6SN7 card. This is also from a similar era to when this TV was made. It's probably early mid-50s, I'd say. And every single tube in this TV will be in here. What this can't do is really early tubes or later tubes. No compact. Well, I shouldn't say that. It's got sockets for early tubes, the 4, the 5, the 6 pin. I have no cards for them, and nobody else seems to either. Not for this model, the 121, which is the lower end. There is a 123 that is a bit more, well, it's a lot more complicated inside, let's just say that. And it's more highly prized, it's more expensive. Those, the cards are widely available, but not so much for this guy. So, my money is on the 6SN7s being goofy. These are dual triodes used for the oscillator circuits. One of them is in an Admiral type with the old font, so it could be the original. One of them is a Westinghouse. Been a while since I used this. So this has no tubes inside of it. There's no warm-up time. A lot of tube testers have tubes inside, and you let them heat up for a while. This does not. Let's see, it's right. Until you put a card in, the thing is kind of doesn't do anything. Alright, so we do line adjust. Good. Cool thing about this is, so there's two triodes in this tube. If you use a tester that has all the rotary switches on it, like a Model 600, you have to do a whole bunch of changes to do each section of the tube. With this, you just hold down a button and you can repeat the tests. And it does the shorts test automatically. You don't have to do anything. If there were any shorts, these lights would light up. So, let the tube warm up for a while. It's probably good enough now. Quality. Alright, one side is good. Alright, so the original Admiral tube seems to be just dandy. Let's check the Westinghouse. I'm hoping it's some of the tubes, because that's the easier thing to replace. And it does seem really weird that the set act very different when I swap them around. Oh, good. Wow, that I was not expecting. Huh. However, that's not the entire story. Oh, 6SN7 card 1 of 3. 6SN7 is a very utilitarian dual triode tube. It can be used for amplifier, it can be used for oscillator, and a number of other things. So they actually have 3 different cards here. Now, unfortunately, I don't know which of the 3 cards is for what. I don't know which of these is the oscillator card, for instance, but we're just going to go through all 3 cards. Also good. And as anybody with experience will tell you, the only true test is in the set itself, because this will not be the exact same conditions as you find inside the actual device. Oh, I suppose I'll do the gas check. If you're wondering why I haven't been, I don't think I've ever found a gassy tube. Or if it is, I mean, it's so noticeable that the device is acting so wacky, like the tube will be glowing or something, so I generally just skip that test. Now, conversely, I could see the shop that worked on this, if they were a shop that did like guitar amps and that kind of thing, may very well have tested all these tubes very thoroughly, and they may have a good tube tester, because that's an easy thing to do. You follow the instructions, do the settings, test the tube. Ah, look at that. So when we do card 3 of 3, this tube is failing the test quite badly. Let's check the other side of it. Side also failing not quite as bad. So again, I don't know what mode card 3 is. Ah, man, it says okay under 50. Ah. And that's where we were. Now, I don't know if that means, if it's supposed to be under 50 and that means good, or if it's reading under, is okay under 50, does that mean over 50 is bad? And if it doesn't, then what is bad? Well, when all else fails, I have a bunch of 6SN7s that I know are good, that I can always pop in there. Now, the other nice thing about this side is almost every tube in it is a 6AU6. So let's do those first, just blow through them all. Because that is my next suspect. In fact, I use 6AU6 so often I took it out of the main deck. I think I have it floating around loose somewhere. It's down in here. Stuck in this pocket. And there we go, 6AU6. I also happen to have a ton of new old stock 6AU6s because they're so common. So next on my hit list would be possibly the 6J6, or I think, what is it, a 6AG5? These are the 2 tubes in the tuner. 6AG5 especially, because that is the RF amp, because I don't think we're getting as much gain as we should be. But that's not what we're testing right now. Right now we're doing a whole bunch of 6AU6s. Should mention too that all these tubes have labels on them. I never looked that close until just now. 6AU6 good, 6AU6 question mark. Does that mean when they tested them they were in the question zone, or does that mean they didn't test them? I have no idea, so I gotta test them all. I've overhauled this tester. I trust it. And this is a mutual transconductance tester. It's not just an emissions tester. I'll let it warm up a little bit more, but this one that they have labeled as good is testing really bad. So forget what I said about that it being a good possibility that they had tested all these tubes thoroughly. No, that is a really bad tube. So that goes in the reject pile. Now let's see how a tube that they had labeled as questionable, or with a question mark, tests. Don't worry, I'm not going to bore you with testing every single tube. I'll just test a few of them, and if any jump out as being really bad, I'll let you know. I'm also a little surprised at how long these tubes are taking to wake up, because I had this running just a moment ago. The tubes are still a little warm. So this questionable one is good. It's not fantastic, but it is in the green, so we'll put that in the good pile. And this one has shorts. Not really solidly on, but the shorts test is flickering. If you guys can see that. So, second bad tube. Doesn't necessarily mean it's a showstopper that you can't use the tube if it's flickering. If it was on dead solid, yeah. This doesn't, when it's flickering, it means that there's, you should have like infinite resistance between pins. This could mean it's got like 10 mega ohms of resistance between like the grid and the plate or grid and the cathode. Depending on how the tube's being used, that might be okay, but I'm not going to spend that much time analyzing the circuit and all that. I'll just put in a new 686. They are plentiful. Alright, I will keep going and let you know what the final tally is. Well, testing all the tubes wasn't too fruitful. 6AG5 and the tuner was a little bit weak, and a couple 6AU6s were a little eh. But otherwise, everything basically tested good. So I went to put the tubes back in, and a couple things happened. One, there was some nasty arcing in the neck of the CRT, and I'm seeing some blue glow occasionally now and then, so there might be an issue with this picture tube. I'll worry about that later. But the other weird thing was, I just couldn't get an image at all. I mean, it's just washed out. I could get some sound. So I started playing around with the tubes a little bit, pulled the shields off to make sure all the tubes were seated and kind of wiggled them around. And I just happened to pull out the second video IF tube and put a new one in while the set was running. And as soon as I put it in, the sound gets a little bit better. But check this out. As the tube will warm up, we get video. And then it fades out as the tube warms up. What the heck? So possibly there's something up with the AGC. So that's the first thing I'm going to check underneath. I may even just try to disable it, because I'm thinking that when that tube comes online, that it's doing something, it's amplifying the signal more. So let me back up a little bit. The AGC, automatic gain control, it works similar to automatic volume control on an AM radio. So the video on a TV is AM modulated. So the really simple way to do automatic gain control is you rectify the signal you're receiving, sync pulses, video, everything, and use that to create a bias voltage used in other parts of the set, typically in the tuner and sometimes in the IF stages as well. So I'm thinking when I put this tube in and starts conducting, as it's coming online, it's going to start amplifying the signal. So the AGC voltage is going to go, say, up. And as the tube conducts more and more, the AGC is going to go up. And if it's not being used properly, it may think that, whoa, the signal's coming in is way too strong, we got to decrease the gain. And it actually essentially kills the gain entirely. So that's what I want to check. So remember, I basically didn't do anything. This section's under a shield, and it's ceramic caps, and I spot checked a few resistors. They seemed okay, so I really didn't do anything to this. So maybe there are some resistors I missed that are way off or something like that. I'm not sure as a head scratcher. Okay, another experiment. I replaced every 6AU6 with a known batch I have of really, really good 6AU6s. They're like a long life version of it, and they're all really, really good strong tubes. Still on video. So I popped out the video detector and went to replace it, the 6AL5, and when I put a new one in, same thing happened. As the tube warms up, we start to get some video, and it fades away again. Which again makes me think it's an AGC issue. And there it starts to come. We just get another arc in the CRT neck, and there the video goes. Unfortunately, I really don't think testing and swapping tubes is going to resolve the issues this set has. What I did was a little homework. I went and looked at the service info, and by that I don't mean the schematic that I've been using, which is nice and big and clear, and I'm pretty sure accurate. No, I went back and looked at the original Admiral service info. I think I mentioned in an earlier part, one nice thing about working on Admirals is they have really detailed service info, and it's been scanned and readily available for free download. Well, they describe each of these functional blocks and how they work. In particular, I read the section on the AGC. They also have a troubleshooting chart. It spans several pages. Do you have weak audio? Do you have buzz in the audio? Do you have no high voltage? Do you have sound and no picture? Hey, that's kind of what we got. Or I should say, we've got a raster, meaning we have horizontal and vertical sweep and the screen lights up, and we have sound but no image. So one thing they suggested is the AGC. Now it turns out this set is more sophisticated than I realized, especially for 1949, as most sets back then, if they had AGC, probably most of them did, they did it very simply by just basically taking the rectified, detected video, as I mentioned earlier, sync and video and everything, and just putting that on a big filter cap like a 0.5 microfarad and running that for the bias on the tuner and IF. This is more complicated, and that's where this transformer comes in. The one that had been was like kind of broken. So I'll try to keep this really simple. Video and the TV using the NTSC broadcast standard is AM modulated. And let's, for the sake of argument, say the video signal varies from 0 to 1 volt. 0 would be black and 1 would be bright white. So while it's scanning across, we got between, say, 0 and 1 volt, and the brightness is being modulated with that. The intensity changes. Alright, well, we need a signal to tell us when we got to the end of the line and when to go back to start the next line. We also need something to tell us when we got to the bottom of the screen to go back to the top. Well, those are synchronization pulses. And again, for sake of argument, let's say those are negative 1 volt. So we'll have squiggly line for the video and then a negative pulse for each horizontal line. Squiggly video info, negative pulse for the horizontal. And after we do a whole bunch of horizontal lines, there'll be a big pulse for the vertical. That's what the sync separator does. So when you go through the tuner and the mixer and the video IF, it's not just video, it's video and synchronization pulses. And you get down here and you get a sync separator. This kind of picks off the synchronization pulses and then they get cleaned up. This vertical integrator here cleans up that vertical pulse, and the horizontal sync discriminator kind of focuses on the horizontal synchronization pulses. Well, those synchronization pulses are fixed amplitude. Again, for sake of argument, let's say that they're negative 1 volt, always. Doesn't matter what the video signal is. The video signal varies all over the place. So imagine it was a nighttime scene, completely black. All the video info would be 0 volts across the board. Or if it was just pure white, it would just be 1 volt all the way across. So if you're using that for your AGC, like say it's a totally black scene, it's going to think, hey, we need to increase the gain because we got a really weak signal coming in, and it'll make it brighter, and what should be a nighttime scene turns out becoming gray. That's the inherent flaw with just using the entire incoming signal to determine your AGC voltage. So, what later sets used, I think, is something called gated AGC. That is essentially what this is using too, only they don't call it that. They don't really call it anything. They just have an AGC tube. But what is this going to? Well, it's a little convoluted, but remember we've got this width control here, which is a primary and a secondary. Well, if we look at this pin 2 here, it goes through a capacitor up to the plate of the AGC tube. Short version, what this does is, this tube only conducts during the horizontal synchronization pulses. So it in essence is only looking at the signal strength during the horizontal sync. And remember that horizontal sync pulse should always be the same amplitude regardless of the video info. So this stuff is kind of a pulse shaping network, and the other side of it goes into the flyback. So it's a little confusing. It's not just a width control. That's kind of a side effect. What this really is this is an AGC transformer, coupling transformer. It's picking off a signal suitable to apply to the plate of a 6AU6 tube, and so on. And then there are associated components to bias it into the proper region and all that. And then this signal, I believe, coming off of the cathode. Let me see where the AGC signal actually goes before I misspeak. The service info said that the AGC goes to the tuner and the first 2 IF stages. So I think that's what this red wire is. Because that is going up to like the screen on these 2 tubes, and well, indirectly to the grid on the oscillator mixer, and to one of the elements on the 6AG6 RF amp. No, you know what? I think I'm wrong about that. So I'm pretty sure this 0.5 microfarad cap here is the filter cap for the AGC. and I see that's going up to the grid on the first two tubes here, and it goes over, boy, it's hard to follow these, to the green wire, which goes to the grid on the RF amp. So I think that is it. So how does that go back to the EGC tube? Again, convoluted, resistor, capacitor, up to that same plate. So I think this is forming a filter on those pulses to make a filter DC in the end over here. And why a 0.5 microfarad cap? Why a large cap? Those horizontal sync pulses, when you get to the end of the line, they're really short. But you want that AGC voltage to be constant during that whole scan period. So really short sampling period and a long hold. So it's actually a sample and a hold circuit. It's sampling the height of the horizontal sync pulse and then remembering that until it gets the next horizontal sync pulse. And it's being scaled and filtered for an appropriate level for the bias. Alright, so that's the theory. It doesn't appear to be working, is my thought. If I knew what the valid voltage range was for this, what I'd be inclined to do is to just, like if I could just ground this point and see what happens if that's a valid range. However, grounding it might be driving the tubes way too hard. Because then I could just, eliminate this possibility of there being something wrong in here. I double checked the wiring on this tube socket and these resistor values, and this all looks to be correct. I did measure continuity on the width control, but now I'm starting to think, well, maybe there is something wrong with it. Because if those pulses aren't right, then everything kind of falls apart. So where to start? Well, I'm going to do the simplest thing first, which is in the SAM service info, they got a resistance chart. That's how I found the problem with several sets recently. So I'm going to check the resistance values on these two pins. So it's also easy to do because you can do it when the set's off. It's resistance between the chassis and each of those two pins. Really easy to check. They also have the DC voltage, which I can also check when the set's on, of course. And they do provide a bunch of waveforms if I hook a scope up. And they have a whole troubleshooting guide, and they have, I think, 6 or so test points throughout the set, key operating points. And they show you what the waveform should be and so on. So if it comes to it, I'll do that. I'm just hesitating right now because I don't have a scope set up. But I'll do the simplest thing first. Because what often is the case, especially with this set, which had so many issues, there could very well be something miswired or shorted lugs on a terminal strip or something like that, and the resistance check will really pinpoint those quickly. Okay, almost instantly found a problem. Not what I expected, not what I wanted to see, not happy about it. It appears the filter choke on the low power supply's got a problem. It should be about 140 ohms. It's measuring 10 times that, 1.4K. How did I find that? Well, pin 2 and 7 on the AGC tube go right to that filter choke and to pin 8. So when I was measuring resistance on pin 2 of that tube, you're supposed to take it with regards to pin 8 on the 6X5. It's supposed to be 140 ohms. I got 1.4K. So I got out or took the meter probes and put them directly across that filter choke, and yeah, 1.4K. That's pretty darn high for power supply filter choke. I can't tell if it's the original or not. Doesn't really look like it's got an Admiral part number on it, so it might be a replacement. Well, as I said, I do have some spare power supply chassis. I don't know if I have any here. I do in storage. I was just looking at them the other day. I don't know that I have any for this specific model. Well, I might in storage or a similar model. But perhaps what I can do is, in a pinch, you can use a power resistor in place of a filter choke. They do not work as well. It's a linear reactive element, linear resistance, whereas a filter choke essentially resists a change in current. It's a reactive device rather than a passive device, so to speak. And then, calculating what resistance value is equivalent to this. I don't think I've got the inductance. I just know the DC resistance, and a 140 ohm resistor is not equivalent to a 140 ohm DC resistance filter choke. That being said, I can try putting in something like 220 ohms. See what that gets me. At least I know what the voltage is supposed to be. I can tinker with that. I could also compensate for this not being as good a filter by tacking on another cap on either side like we've got up here to do a little more filtering. But before doing that, I'm kind of curious to measure this voltage and see what it is without, or with whatever situation's going on in here. Because it's not, well, I shouldn't say, I was going to say the dead open, but I'm measuring it in circuit. However, that should be an infinite resistance, and the tube should be an infinite resistance. So if I'm measuring from that point to the other side of the choke, I'm measuring resistance on that. So anyways, how can a filter choke be 10 times the resistance it's supposed to be? Well, we obviously don't have shorted turns, or we go down in resistance, so it's either a substitute that's the wrong value, or there are some corroded wires inside, maybe, partially burned open, something like that. I ended up tacking a 390 ohm 3 watt resistor across the choke. That got the voltage up a bit. It's pretty close to what it's supposed to be now. Really didn't make any difference to the average of the set though, so what I'm trying to do now is fix the AGC. I measured it and it was like minus 0.5 volts. Well, I read the alignment instructions and they said you should set it to negative 4.5 while you're doing an alignment. And they say to take a battery, a 4.5 volt battery, and just clip it right in. Well, I had a 3 volt lithium battery handy, so I tacked that in. It's not quite 4.5, but it's more than 0.5. And don't do what I just did. Never, ever, ever do what I just did, which is to tack solder a wire onto a battery. It could explode. Don't do it. So let's see what effect that had. All the resistances on the AGC tube, by the way, checked out okay, and I checked both the high and low B+, and they're okay. Still don't know what I'm doing. I'm going to pop out one of those 6AU6 tubes again. Let's see, I'll pop in a cold one. Now, if you're wondering, how come when I first powered this setup, we kind of had something? I think it's because one or two of these 6AU6s were bad and had some partial shorts, and they were affecting. So, in a way, those bad tubes were letting a signal get through, whereas good tubes don't. Yep, same issue. As the tube warms up, we get video. Well, it's kind of staying this time, though. Sorta, kinda. Now, the tube I just put in was one of those original tubes that had tested bad, so. Interesting. I'm not crazy about this focus control knot. I can never really get good focus with it, but one thing at a time. I think the high voltage is lower than it should be, so it's going to affect things. I'm going to play around with this a bit and see if I can get a sync and just leave this hardwired in for the fixed AGC. So here's that horizontal oscillator coil. Now the cap on there is the plastic film cap that was there originally. I was curious to see how it would perform. Now I did pick up a C0G ceramic, and I'm curious. Now the issue we're seeing is not because this is getting hot drifting off value, but the tolerance on these, it's probably 10%. I think the ceramic might be more like 5%, so maybe this is just a bit off value. Plus, let's see what the original was. I don't think the original was a 5600. Or sorry, 3900. 0.0039. Yeah, what do they have in there? Actually, I think it is a 392, but yeah, it is a 392. So it is a 3900 they put in there, but again, it could be far enough off that there's just not enough pull range on this coil adjusting it. So anyways, it's a simple enough thing to do is to, so I just tacked that in, is to pop that out and put a different cap in there. On the other hand, I measured the cap that had been in there with my cheapo component tester, and it measured about 3,812. Well, I took the C0G cap I was going to put in there, and it measured about 3,700 and a little bit. In other words, it's lower in capacitance, and I think this thing is running high. So I just on a hunch, I threw in a 4,700 just to see what happens. Also, when the horizontal oscillator is running off frequency, the flyback is not running at its resonant frequency, its optimal frequency, so the high voltage is going to be low. When we get all this stuff adjusted right, the high voltage should come up and we should get a brighter image. Interesting. Because something else I did is I put in a different 6AU6. Seems the only way I can get an image going through this thing is to put in one of these goofy original 6AU6s. This thing has really got me scratching my head. And there it comes in. Oh, it almost locked. Alright, go back to adjusting that coil. And now it's in as far as it can go. So back it out. Which looks like we kind of lost our image, or at least it's not as pronounced as it was. That's not going to help matters. What is going on with this set? Well, what the heck? I'll throw in a different 686. Oh, my AGC bias clip fell off. Maybe that's why these tubes are starting to act weird. Okay. Come on, image, stay on there. Damn, I still got image fade. I'm connecting and disconnecting that fixed AGC bias. It's doing something, but not as much Sorry for the god-awful camera work. It's not doing all that much when I hook up the fixed bias. Grr. Alright, well, I will keep poking around and see what I can figure out. I figured since there's so much weirdness when I swap out the 6AU6 tubes in the video IF chain, I better take a closer look at that. And boy, we got some resistors that are way off. It's basically a string of 1K resistors in here. So here's the closest one to the tuner. Should be 1000 ohms. 3.4K. Hope you guys can see that. And here's another. I clipped out of circuit just to make sure. 1.6K. And here's another. 1.9K. Those are all really, really far off. This one, hey, it's just about dead on 1K. And the last 1K resistor, 1.3. Bad, but not terribly bad. Alright, so then there's also a cathode bias resistor on each of these 6AU6s going from cathode to ground. Let's check each of those. This should be 39. 40. Not too bad. I think this one's supposed to be 68. Ooh. 102. Yeah, I'd say that's a little far off. And this final one should be 100. And come on. 244. Alright, so we got several resistors that are 2 and 300 times off. Huh. In case you're wondering what that was, apparently we've got a curfew in Chicago that just took effect. I was just going to go out. Well, that blows. I guess I got no excuse but to replace all these resistors now. And I'm surprised. I mean, I'm not surprised. I already mentioned in an earlier video that the low value resistors, cathode bias resistors, often go off value. I did not expect to see 1K resistors that are measuring 200-300% higher. So what effect does that have? The cathode resistor kind of sets the operating point for it. The other resistors, I think, are, well, they're certainly in the AGC circuit. So, here, make sure you guys can see this. So that is the AGC point right there. Because there's 27K resistor to the 1K resistor and over to another 1K resistor. So these two are off. And then that goes up to the grid. And then there's that 39 ohm resistor there and 39 there. Oh, what did I say? That should be 68. It should be 39 and it measured 100. And there's the 100 that measured, I think, 245. So in other words, the operating points on these tubes are all out of whack, and the AGC voltage is going to be kind of out of whack. That being said, I still wouldn't expect it to completely kill the video like it's doing. I'm feeding it a really nice, clean, strong signal, but it couldn't hurt to go ahead and replace those. Well, after a whole lot of twiddling, here's where things stand. I can kind of get the horizontal into the right range. But there's no sync action. And it seems like, well, I thought that I had pretty good vertical lock. Well, maybe that's kind of flaky too. Now it seems the vertical is pretty unstable, so sync separator might be a really good place to look next. Now, unfortunately, replacing all those resistors in the IF did nothing. or at least nothing significant. I still have the AGC bus hardwired. I got it on negative 6 volts now to get a signal to come through. And I have worked a bit on the tuning slug and the tuner, and I tweaked the sound a little bit by ear. But still a far cry from what it should be. And it's super sensitive to tubes. I tried about a dozen different 6SN7s and only 2 of them will oscillate. I've gone over the whole oscillator circuit with a fine-tooth comb. The voltages are within the right ballpark. It's wired up. I checked the schematic both in the SAMs and the riders, and that all looks okay. Swapped a whole bunch of different caps under this coil, and finally I went with a Mica 3300. It finally kind of got me in the right range. Remember, original was 3900. And it seemed like a 4700 came close to working, and a few other values. It's not acting at all like I would expect. In other words, you would think the lower the capacitance, the higher the frequency, the higher the capacitance, the lower the frequency. No. Now this has an AFC action to it. There's half of the 6SN7 is like a reactance tube, and there's a horizontal sync circuit. So it's trying to lock onto the incoming frequency, in other words. So it's not quite so simple. That's what I'm getting at. And the part number on this coil does match the schematic, but I kind of wonder, maybe the slug inside this is damaged, like part of it broke off. That could certainly explain a whole lot of things. But boy, this is sure aggravating. Now, I do have one simple thought about the video I have. It could simply be really out of whack with the alignment. If somebody twiddled these various tuning slugs up here, it could be way off. Now, it doesn't really look like they have. Usually you can kind of tell, like on this one where it's dark, you can tell it hasn't moved in a long time. And where I tweaked it a little bit, it's kind of shiny because of the brass gets rubbed. Now, I'm sure these could have been tweaked 20 years ago, and the corrosion is uniform now. But that is certainly a possibility. And it just so happens that when I pluck a tube out and put it in and it's cold, while it's warming up, it briefly kind of works. But I haven't encountered anything quite like this before. I've spent way more time than I wanted to on this set, and still a ways from getting what I want.